We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the ENSO cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern US and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the US. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the US wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside.
Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts use equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes, just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour. So it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest the storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities. If there were cataclysms on Earth every 5 minutes, living conditions on our planet would be almost the same as 4.5 billion years ago. Back then, seas and oceans boiled, lightning struck everywhere, tectonic plates changed their shape, lava flowed from volcanoes, and worse, no internet. The Earth resembled a vast boiling cauldron where life was gradually being created. If it starts to boil again, this cauldron could destroy almost all life on the planet. Consecutive cataclysms. Won't hurt to pretend. Let's imagine, shall we? Good morning! You wake up in a small underground bunker. The seismic sensor indicates that a 7-point earthquake will start in a few minutes. You pack a huge waterproof backpack and go upstairs. The underground bunker is protected from seismic activity. It moves with the ground, so you're safe here. But you need to leave the shelter because supplies are low. Also, yesterday, you picked up a radio signal telling all survivors to go south immediately. The coordinates they gave aren't far from your location. You have to hurry, though, before the landscape changes again. You open the hatch and find yourself in the middle of the desert. The sun is almost invisible beyond the gray sky. The ground is shaking, but you're not afraid. There are no houses or buildings, nothing to fall on you. You keep your balance perfectly, and the earthquake doesn't knock you off your feet. It's like jumping on a trampoline. The only danger is the deep chasms in the ground, but you can easily jump over them. After such an extreme morning warm-up, you decide to have breakfast. You take a tin can out of your backpack. You have a few minutes before the next disaster, so you eat and remember how your great-grandfather told you how all this started. Before all of this, the planet was divided into territories called countries. Millions of people lived in them, and then something terrible happened. The tectonic plates started to move, and the air temperature and atmospheric pressure began to rapidly change. In one day, earthquakes destroyed entire cities. Tsunamis and floods washed away the remaining ruins. Volcanic ash blocked the passage of sunlight. Forest fires destroyed almost all vegetation, and eruptions poisoned the air. Only a few people managed to adapt to such harsh conditions, and you are a lucky duck to be one of them. As you finish your breakfast, you're distracted by another ground tremor. Time to move on. Many people travel around the world alone, as they consider it a safer way of life. Some people form small communes, but no one ever stays in one place for too long. Your whole life is in motion, but you don't panic. One of the main rules during natural disasters is to remain calm, so all survivors have steel nerves and excellent physical training. You run a few miles south and suddenly smell something strange. You put on a gas mask. The earthquake has created a limnic eruption. Natural carbon dioxide is released from the ground to the surface. You feel comfortable in a gas mask, but can't run fast while wearing it. Far up ahead, you see a green forest, a rare place that was not affected by fires. You take off the gas mask and go to the tree to take shelter in the shade from the scorching sun. This green area is rich in vegetation. Colorful flowers, strawberries, and many other berries grow here. But you're concerned. Such fertile land comes from being near volcanoes. It spews underground magma rich in vitamins and minerals, so vegetation grows. You can see a high mountain in the distance. This is the volcano. An underground push occurs again and provokes an eruption. You gather strawberries and run away from this place as far as possible. Lava pours from the volcano's mouth and makes a fire in the forest. You unhook a folding scooter with a motor from your backpack and drive away from the fiery mountain as fast as you can. The sky is covered with volcanic ash, but this is not for long. A strong wind grows with each passing second. You realize a hurricane is moving in your direction. You take out a small shovel and dig a hole in the ground. The soil is dry, but you have enough strength to dig a small ravine in a couple of minutes. You dive into the shelter and cover yourself with a protective tent. The hurricane blows the volcanic ash in different directions, and the air becomes clear again. But the fire doesn't stop. The wind spreads through the forest. You get out of the ravine and put on the gas mask again. There's a lot of smoke around, and it's unbearably hot. You know the hurricane couldn't just appear without any reason. Hurricanes are formed when warm, moist air collides with the sea surface and rises to the sky, so there's water nearby. Great, because you're thirsty and want to cool down. A loud sound erupts behind you. You turn around. A massive wave of water approaches the fire. Without panic, you take your life jacket out of your backpack, remove your gas mask, and put on a diving mask and fins. The wave blows you off your feet, but you don't drown. Over the years of survival, you have learned to swim very well. You grab a passing tree and wait patiently for the flood to be replaced by another natural disaster. For 5 minutes, you sail under a black, stormy sky that sparkles with lightning. Despite the waves, you try to row south. It's getting pretty cold. You finally see the shore, but this is not a land, but ice. A strong wind brought a cold cyclone, which caused a fast temperature change. It's like you're in Antarctica. Snow and blizzards are all around. It's freezing, but you take out a thin space blanket made from foil and walk slowly south. Under your clothes, you put crumpled paper, bubble wrap, pieces of cotton. All this also helps to warm your body. Along the way, you collect several bottles of snow to melt later. Icicles form on your face, and you can't see because of the snowstorm. Suddenly, the snow begins to squish under your feet. The ice melts and turns into water. A hot stream of air blows into your face. You find yourself on hard, dry ground, looking up at the sky, then at your watch. 5 minutes pass, and the sky is again covered with black clouds. You take a metal plate out of your backpack and cover your head with it. A few seconds later, you are hit by heavy rain and hail. Giant balls of ice knock on the metal shield, but you go calmly and even with a smile on your face. The ground becomes wet and loose from icy rocks. When the hail ends, you pull out all the heat-insulating materials from under your clothes and hide them in your backpack. Then you lay out a few long spokes of steel. The spokes are wrapped with copper wire. You connect the spokes to each other, making one long antenna. You stick it in the ground and run away. After the hail from the rain clouds, lightning strikes the ground. More precisely, it hits the lightning rod you've just built. You wait for the storm to end, then take the lightning rod apart and return it to your backpack. An intense heat begins. You drink some melted snow and break your way through the desert. The Earth trembles, and your adventure begins again. Earthquakes, carbon dioxide, fires, floods, snowfall, tsunamis, lightning, and again and again and again. With the help of a compass, you continue your journey and reach your goal a few months later. You see a long antenna sticking out of the ground. This is a place mark for entering an underground city. The city is built from dozens of massive bunkers connected to each other by tunnels. The city walls don't allow radiation to pass through, and they don't bend from daily earthquakes. People learn to extract energy from the ground. The Earth's core gives heat. This heat boils water, then steam is formed, and electricity is created at special stations. People get water from underground lakes and rivers. Instead of the sun, ultraviolet lamps are installed everywhere, which provide people and plants with necessary light. Natural disasters happen on Earth every 5 minutes, but humanity still has a lot of space underground.
Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia. These are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference, but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time. and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, people in different parts of the world woke up in the middle of the night because it was so light outside, they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma-ray bursts. You can't come across this kind of radiation in your everyday life. A gamma-ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma-ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma-ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a super eruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sinkhole within minutes. Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? All right, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reached the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us. Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes caused tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those. The Boxing Day Tsunami, Indonesia. An undersea earthquake starts in the morning. Its tremors cause a series of tsunami waves. The largest reaches the height of the Arc de Triomphe in Paris. Unzen volcano mega tsunami. A powerful volcanic eruption triggers a landslide from a 4,000-year-old lava dome. It sweeps through the city of Shimabara and reaches the sea, setting off a mega tsunami. The Vajont Dam mega tsunami, Italy. A landslide drags 9 billion cubic feet of forest, soil, and rock into the lake. A dark wall of water covers the sky over a tiny village at the bottom of the Vajont Dam. Then, with a deafening roar, the wave overtops the edge of the dam, taking out everything in its path. Mount St. Helens mega tsunami, USA. As the volcano erupts, the upper 1,500 feet of Mount St. Helens collapses into a massive landslide. Part of this avalanche plunges down into nearby Spirit Lake, which splashes the lake waters into a series of waves almost as tall as the Eiffel Tower. Alaska's Lituya Bay tsunami. A landslide caused by an earthquake creates a megawave. It surges over the headland and washes away trees, plants, and soil down to bedrock. Molokai, Hawaii. A third of the East Molokai volcano caves in and collapses into the Pacific Ocean. This causes a tsunami the size of the second tallest building in the world, Shanghai Tower. The waves reach Mexico and California. The Yucatan asteroid tsunami. The asteroid, which is rumored to have wiped out dinosaurs, strikes the Yucatan Peninsula. It creates a mega tsunami, the largest in Earth's history. The first wave's almost twice bigger than the world's tallest building, the Burj Khalifa. Hurricane Mitch. Mitch forms in the western Caribbean Sea. Soon it strengthens to become the 8th most powerful Atlantic hurricane ever. The storm pours 4 inches of rain per hour for 2 days in Honduras. It causes terrible mudslides and floods. Hurricane Allen. Rare and extremely powerful, the storm is one of the few to reach Category 5, the highest possible. It causes more than $2 billion in damage. The Great Hurricane. After tearing down Barbados, the storm moves on. It strips the bark off the trees growing on Martinique and St. Lucia and travels further. This horrific natural disaster lasts for 6 days. Hurricane Dorian. It's the most powerful tropical cyclone to hit the Bahamas. The hurricane flattens most of the structures on the islands and sweeps them into the sea. Hurricane Wilma. The storm occurs in the Caribbean Sea near Jamaica and heads to the west. 2 days later, it gathers enough power to turn into the most intense hurricane ever recorded in the Atlantic Ocean. Hurricane Patricia. A regular storm develops a well-defined eye and turns into a Category 5 hurricane within a mere 24 hours. At one point, it travels faster than a Ferrari moving at its top speed. It makes Patricia the world's most intense tropical cyclone ever recorded. Kamchatka earthquake. It happens in the early morning 80 miles away from the shores of Kamchatka. The earth tremors produce a tsunami. The first 2 waves are catastrophic, up to 60 feet high. The third one's much weaker. Valparaiso earthquake, Chile. It happens at about 5 a.m. along the boundary of 2 tectonic plates. The tsunami, triggered by the earthquake, wipes out 620 miles of Chile's coastline. Tohoku earthquake, Japan. The first earth tremors start at a great underwater depth. The earthquake is so strong it moves Japan's main island. It shifts the planet on its axis by up to 10 inches and increases its rotation speed. The disaster also triggers a tsunami with 133-foot high waves that travel 6 miles inland. Indian Ocean earthquake, Sumatra. A rupture along 2 tectonic plates sets off an undersea earthquake. It begins at about 8 a.m. near northern Sumatra, Indonesia. It makes the planet vibrate nearly a half inch and sets off earthquakes all over the world up to Alaska. Good Friday earthquake, Alaska. The most powerful earthquake recorded in North America lasts for 4 minutes and 38 seconds. A 600-mile-long crack causes terrible landslides and a 27-foot tsunami. Areas 200 miles away get raised by 30 feet. Other places permanently drop 8 feet. Valdivia, Chile. The Great Chilean Earthquake starts in the afternoon and lasts for no less than 10 minutes. The disaster affects an area the size of California. It triggers tsunamis that reach the shore of Hawaii, Japan, the Philippines, Australia, and New Zealand. The average tornado usually lasts less than 10 minutes, but there are exceptions. El Reno tornado. It's considered the world's largest tornado based on width. At its peak, the twister reaches 2.5 miles across. The Perryville tornado, U.S. It occurs at about 2 a.m. and starts with snapping hardwood trees and breaking down stone constructions. Then the whirlwind becomes stronger. It levels 2-story buildings, flips and tosses cars as if they were toys. Bridge Creek Moore tornado. When the twister gets into the town of Bridge Creek, its width is at its peak, 1 to 1.5 miles. The wind speed of the tornado reaches more than 300 miles per hour. This natural disaster causes $1 billion in damage. Manitoba, Canada. An outstanding tornado rages for nearly 3 hours. It breaks tons of trees and utility poles, damages roads and farmhouses, but miraculously misses every town on its path. Tri-state tornado, U.S. The world's longest-lasting single tornado travels 220 miles through Missouri, Illinois, and Indiana. The average tornado's path is usually no longer than 5 miles. Tupelo, Gainesville, U.S. An outbreak that consists of at least 12 single tornadoes wipes out everything on its way. The accompanying rainstorms also trigger severe flash floods that make matters even worse. Valjean landslide, Italy. At 10 p.m., a landslide with a volume of 100 Great Pyramids of Giza breaks off from the top of Monte Toc. It falls into the Valjean Dam Reservoir, producing a tsunami wave taller than the Golden Gate Bridge. Yunnan, China. An avalanche of rocks, stones, and mud, so big it could fill up Sydney Harbor, forms a dam on the Jinsha River. The Hida River, Japan. Triggered by a rainstorm, 300,000 Olympic swimming pools of debris flows down before getting stopped by another, earlier landslide. Along the way, the landslide sweeps 2 buses off the road. Peru. A rockslide dams the Rio Montanero, a long river running through the center of Peru. The whole process takes no more than 3 minutes, which means the landslide moves at a speed of up to 87 miles per hour. It also leaves a trail of debris 5 miles long. The Usoy Dam, Tajikistan. Set off by a magnitude 7.4 earthquake, the rockslide falls into the Murghab River and blocks its flow. That's how the Usoy Dam, one of the tallest in the world, appears. Mount St. Helens, USA. At 8:30 a.m., after much buildup, a volcanic vent finally gives way and sets off a catastrophic eruption, which makes the entire north side of Mount St. Helens fall away. It's the world's largest recorded landslide. North Bonneville, U.S. In the middle of the 15th century, a great earthquake occurs. An incredible amount of debris rushes down from Table Mountain. It covers more than 5 square miles and blocks the Columbia River with a dam 200 feet high and 3.5 miles long. Welcome to the Spirit of Discovery cruise ship, which will take you on an unforgettable sea voyage around the Canary Islands. The azure endless ocean, delicious food, the highest service, premium cabins, and a terrible nightmare that you will probably remember for the rest of your life. This is exactly how one luxury trip of the Saga Cruises Company ended last year. Instead of relaxing during the cruise, passengers felt fear and horror, and even had health problems. And that's why. On October 24th, the Spirit of Discovery liner started a 2-week cruise around the Canary Islands. There were about 1,500 people on board. About 1,000 were passengers, and the rest were crew members. The first week went great, but then the liner encountered a serious problem called nature. There were strong winds and big waves. The captain decided to return to the UK ahead of time, but the decision was made too late. The ship was caught in a severe storm in the Bay of Biscay. A powerful wind with a force of 11 points hit the vessel. To make it easier for you to understand, the 11-point wind is able to tear out trees together with roots, destroy residential buildings, and plunge entire cities into chaos. Such a storm is rare, but Spirit of Discovery was unlucky enough to get into its epicenter. 11 points is the penultimate place on the Beaufort scale, which determines the wind rating. The most powerful storm has 12 points, and this is a hurricane. The wind reached a speed of 65 miles per hour, which is about the same as the average speed of a car on a highway. Not only did it push the Spirit of Discovery, but it also raised huge waves 25 feet high. Just imagine a wall of water the height of a 3-story building collapsing on a lone ocean liner. At that moment, the captain sent a message to all the passengers through the cabin speakers so that no one left their place. And his voice sounded worried enough. All the passengers had to lie down and hold on tight. According to the witnesses' words, the ship remained caught in the storm for about 15 hours. They held on with all their might so as not to crash into the walls and floor. All this time, tables were flying around the ship, dishes were breaking, furniture was moving all over the cabins. The waves smashed windows, partitions, and doors. Some people were knocked down because they couldn't hold on for so long. The storm hurled the passengers from ceiling to floor, from wall to wall. The ship's crew turned the dining room into a medical area to provide assistance to those who had been hurt. Despite the difficult and terrible conditions, the ship's team did a great job. They regularly informed passengers about the current situation and tried to calm everyone down. There was no panic and chaos on board. When the storm finally ended, the ship continued its journey and finally reached land, where medics urgently evacuated 8 passengers to the hospital. One of them was never able to survive this storm. It's good the ship didn't meet a rogue wave during the storm. This is a natural phenomenon that can appear during a storm and even in still water. It's a giant wave with a height of 60 feet. Like a 6-story house, it collapses onto a ship with incredible speed and capsizes it. And then the wave suddenly disappears. This is no joke. A similar wave has been recorded in the Gulf Stream off of Charleston, South Carolina. It's scary to get in its way. Now, let's go back to the past to remember one of the most terrible maritime tragedies. No, we're not talking about the Titanic. We'll talk about the Greek liner Laconia, which set sail from the English port of Southampton on December 19, 1963, with more than 600 people on board. However, just 3 days later, a terrible tragedy happened to the ship in the boundless waters of the Atlantic. At 11 p.m., in the barbershop hall, an electrical malfunction occurred. The problem led to a fire, which quickly spread to other rooms. The crew couldn't cope with it, since the fire was spreading too fast. The ship's team turned on the fire alarm, but there was no command to leave the vessel. Only 2 hours later, the captain ordered the passengers to evacuate. All this time, people were either relaxing in their cabins or enjoying a party in the ballroom. The crew was probably trying to put out the fire without causing panic. However, when the situation became critical, the evacuation began. People panicked and ran to the lifeboats, but many didn't manage to get inside. One of them was John Morris. He survived this catastrophe and shared his memories of how he put his family in a lifeboat while he stayed on board the ship. He didn't even have a life jacket. Since there was nowhere to go, the ship's crew opened a bar so that people could relax a little. However, at that moment, boilers began to explode inside the ship, and it became clear the vessel wouldn't stay afloat for too long. John Morris decided to jump into the water right in his tuxedo. As soon as he was overboard, he grabbed onto a piece of wooden deck cargo and swam as far away from the ship as he could. The giant liner could sink at any moment, and when such a huge object goes down to the seabed, it forms a water funnel that pulls along everything around. Rescuers arrived at the scene sometime later. Fortunately, John Morris's pregnant wife and young son were alive, but his mother-in-law unfortunately didn't survive the disaster, like many other people that day. Of course, after this incident, the Greek Ministry of Merchant Marine initiated a thorough investigation. For 2 years, they collected information from passengers and the captain, studied the technical characteristics of the ship, and eventually came to certain conclusions. According to them, the ship's crew gave the evacuation order too late. Not all passengers were able to get into lifeboats, but half of those boats remained on board because of the chaos that prevailed during the evacuation. Several officers of the liner were accused of negligence, but the captain and his first mate received the most criticism. As for John Morris, he stated that he felt himself under protection that day. Another unusual story happened on a cruise ship relatively recently. Spoiler alert, the ship didn't sink, there was no evacuation, and the weather was good. However, for many passengers, this journey became a real challenge. Imagine that you've been working for a long time and saving up money to go on your dream trip on the Celebrity Mercury cruise ship in the Caribbean. You arrive in South Carolina, from where the ship begins its journey. You get on board, looking forward to a week's rest. At first, everything is fine. People are having fun, chefs are cooking delicious dishes, and beautiful daytime landscapes turn into night parties. But then suddenly, many passengers start throwing up. Someone is in a hurry to go to the toilet, and someone stays and vomits right in the halls. The cruise turns into chaos. More and more people feel terrible because of unknown poisoning. You also visited the restaurant and eaten seafood, but fortunately, the disease has avoided you, which can't be said for more than 400 other passengers. Almost every 1 in 4 people on board face gastrointestinal problems. There were almost 2,000 people, and a quarter of them are in bad condition. Crew members do endless cleaning. They wash the deck, give people nausea pills, and ask them not to leave the cabin till the illness passes. The captain sends several samples ashore to determine what caused the poisoning. Unfortunately, the cruise is already ruined, and all the passengers have unpleasant memories. So the company organizing the trip issues certificates that can be used on future cruises. is not the most pleasant experience, but it's still better than nothing. Now, imagine if, instead of just feeling sick, people got infected with some kind of bacterium that would turn them into zombies. It would be much more exciting and scary. Now, do you think you could survive on such a ship full of zombies? And how would you do that? Tell me about it in the comments.
There's something really bizarre going on at these 12 points scattered across the Earth. The vile vortices, as they're called, are these creepy spots over the Tropic of Cancer, the Tropic of Capricorn, and the North and South Poles, where weird forces seem to take over. You've probably heard of the most famous one, the Bermuda Triangle. It's believed that more than 50 ships and 20 airplanes have mysteriously disappeared in this area, which is located between Florida, Bermuda, and Puerto Rico. But what most people don't realize is that the Bermuda Triangle actually has 11 siblings, and these other spots can be even more terrifying. Let's start with Mohenjo-Daro. This was a thriving city located in what is now Pakistan. Built around 2500 before the Common Era, this urban center was once home to about 40,000 people. But then, suddenly, people abandoned it by the year 1700 before the Common Era. In the 1940s, an archaeologist discovered 39 human skeletons at the site, which fueled the theory that the city was invaded by some other civilization at some point. But honestly, it's hard to confirm that, since archaeology doesn't really explain the city's sudden destruction or the disappearance of its people. It's led to a bunch of bizarre theories. One of them talks about an ancient extraterrestrial race that might have lived there, and a malevolent wind that swept through the city. Another ancient city with a similar mystery is the Great Zimbabwe. Its construction began in the 11th century, and at its peak it housed up to 18,000 people. But for reasons we'll probably never fully understand, it was abandoned in the 15th century. Archaeologists were really interested in this place, and that's when things got even weirder. They found 8 of these birds, now called the Zimbabwe birds. These soapstone sculptures were found sitting on stone columns that were over 90 centimeters tall. Nothing like them has ever been found anywhere else, and their meaning is still a total mystery. Some think each bird represents a new king, but other theories suggest they were ancient animals very dear to the people who lived there. Adding to the mystery, local legends talk about a strange, short man who's sometimes seen wandering around, but he always disappears before anyone can get close. Then there's Easter Island, another one of the 12 vile vortices. It's located in the eastern Pacific Ocean, and it's famous for its nearly 1,000 enormous statues called moai. We still don't know what they mean, or how they were made. Some of them are almost 30 feet tall and weigh as much as 80 tons. Today, it wouldn't be that tough to move and carve these statues, but we're talking about a period between the years 1100 and 1680. So nobody really knows how they did it. Some specialists believe these statues were carried across the island, while others think they were pushed on log rollers. But the most bizarre theories suggest extraterrestrials were involved. Algeria is another land rich in ancient mysteries, and one of the most fascinating is something called the Djedars. These are 13 monuments with square stone bases and angular mounds, built between the 4th and 7th centuries. But the weird part is, no one knows their purpose. One of them had an inscription in Latin, but it was so worn down that the message was nearly impossible to read. The best guess so far is that these monuments were probably tombs for royalty, although no one knows exactly who was supposed to be buried there. What we do know is that there are many myths related to strange disappearances in the region. The next mysterious spot is located south of Tokyo in the Pacific Ocean, and it's called the Dragon's Triangle. Does that name ring a bell? Yep. Just like the Bermuda Triangle, this area is known for strange disappearances of airplanes and ships. One of the most chilling stories dates back to 1945, when a plane allegedly vanished. The pilot supposedly sent a radio transmission right before the aircraft disappeared, claiming that something strange was happening in the sky, like it was opening up or something. While this story is definitely eerie, the truth behind it and many other Dragon's Triangle legends is still up for debate. If you type Hamakulia volcano into Google Earth, you'll find it located in Hawaii's Ring of Fire. But this place is so shrouded in mystery that it's hard to find much information about it. Some legends speak of unusual electrical energy being detected in the area, and there's even a story about an eyewitness who claimed to see a plane flying over it totally disappear from the radar. Another eerie spot is the South Atlantic Anomaly, which is an area on Earth where natural radiation flows out of control. While this doesn't affect our daily lives on the surface, it has a pretty big impact on Earth's atmosphere. The radiation there is so intense that it can knock out the onboard computers of spacecraft and interfere with the data collected by satellites passing through the area. To deal with this, specialists had to add an additional shield to the International Space Station. The South Atlantic Anomaly is also linked to a weird event that astronauts experience called cosmic ray visual phenomena. They've reported seeing random flashes of light or shooting stars out there in space, but it's all just some kind of illusion. From wild radiation to strange seismic activity. The Wharton Basin in the Indian Ocean is a place known for unusual tectonic events. In April of 2012, a massive earthquake measuring magnitude 8.6 hit the region. This was considered the largest intraplate earthquake ever recorded, meaning it happened within a tectonic plate rather than at its boundary. This caught the attention of scientists, who now speculate that the region might be forming a new boundary between the Australian and Indian plates. But for now, this is all still one big mystery. Now let's head to the Pacific Ocean. More specifically, to the New Hebrides Trench. This submarine trench is about 750 miles long and 45 miles wide. It formed when the Australian plate slid under the New Hebrides plate. There's no doubt that this is one of the creepiest and deepest spots in the ocean. The danger isn't just down in the deep sea either, as this trench has been connected to several earthquakes that affected New Caledonia and Vanuatu. This area also has some strange features. For example, when scientists explored it, they didn't find a single grenadier fish down there. This type of fish is one of the most common deep-sea creatures you would expect to see in trenches around the Pacific. So why aren't they around the New Hebrides Trench? Maybe they know something we don't. The two remaining vile vortices are the North and South Poles. These two are on the opposite ends of the planet, but they share one thing in common: strange disappearances. One of the most famous stories from the North Pole happened in 1897. 3 brave explorers set out on a journey to reach the North Pole using a hot air balloon. But they never completed their mission. Their mysterious disappearance remains one of the most intriguing, unsolved mysteries in the history of Arctic exploration. The South Pole is also known for similar mysteries. It's believed that hundreds of people may be buried beneath the snow and ice of the coldest continent on Earth. Even with all the advancements in technology and knowledge, the South Pole can still be extremely dangerous for anyone who ventures there. The temperatures can drop to almost minus 130 degrees Fahrenheit, and the winds can get up to 200 miles per hour. And that's definitely enough reason to stay away. Now that you're familiar with the 12 vile vortices, let me tell you something even stranger. If you look at a map, you'll see that these places are arranged in a way that looks pretty similar across the globe. Here's the weird part. If you connect these spots where unexplained events have occurred, you actually form the geometric shape of an icosahedron. This could be just a huge coincidence, but the fact that these mystery spots align with this shape makes them even more intriguing.
Something interesting has recently happened in South Dakota. It was all over the internet, so perhaps you already know about it. In July of 2022, the sky in this state suddenly turned green. So, what happened there? Was it caused by a human or by nature? Let's find out. Tuesday, July 5th, 2022. Shortly after a heavy storm, the sky over South Dakota in the US was still overcast. Locals finally went outside and saw that the sky had an intense dark green hue, and they'd never seen anything like that before. People said that it looked like something straight up from science fiction, or even a horror movie. Unsurprisingly, South Dakotans immediately started spreading the news all over social media. People shared their beautiful, yet very eerie pictures on Twitter. They showed the sky over the city of Sioux Falls and a few other towns. Even though it may look like something supernatural, in reality, this is not a terrifying phenomenon at all. It's a simple play of the light and the atmosphere. Something like this happens quite rarely, and usually means that really bad weather is approaching. And that's also true to what happened in South Dakota. Just before people started sharing photos, a thunderstorm swept through the town of Sioux Falls. This was confirmed by the U.S. Weather Service. This hurricane was terrible. The wind speed was about 100 miles per hour. According to the Beaufort scale on wind speeds, this is the fastest and most destructive storm. There are only 12 numbers on this scale, and the maximum wind strength starts at 73 miles per hour. But why isn't this all over the news then? Well, because it's kind of a usual thing for the residents. Thunderstorms occur very often in the United States, especially in the warmer months. And 1 out of 10 such thunderstorms can become something serious, like a tornado. This one wasn't an exception. It was the so-called derecho storm. Derecho is very widespread and long-lived. It's actually a combination of a fast-moving group of severe thunderstorms and downpours. People often say that a derecho is as strong as a tornado. Still, there's a difference between them. A tornado is a vortex, a rotating column of air. It's usually about 500 feet in diameter, although sometimes its width can reach up to 2.5 miles. I don't envy those who would stumble upon that. But the main point is that they rotate. The wind moves very fast in a circle, near some invisible center. A derecho is a strong thunderstorm, or a system of strong thunderstorms with straight-line winds. In other words, it doesn't spin. Instead, the derecho chooses a point somewhere and simply runs to it, like a very motivated marathon runner. If we compare a derecho to an ordinary tornado, the latter has 6 levels of strength, from 40 to 380 miles per hour. So a derecho is kind of like a small, average level 1 to 2 tornado. Usually its speed is within the range of 73 to 113 miles per hour. And in both cases, they can be accompanied by severe thunderstorms, lightning, and rain. But still, these are different things. A storm becomes a derecho if the damage trail left by it exceeds 240 miles, and if the wind speed is at least 58 miles per hour. It's quite difficult to predict. It can form even on a clear day when meteorologists don't even anticipate any storms. And then, the winds appear suddenly. It's so surprising that they may even feel explosive. But the National Weather Service tries to warn people at least half an hour or an hour before this happens, so that residents have time to prepare and hide. It wasn't any different this time. The storm swept through almost all of South Dakota, as well as the states of Minnesota and Iowa. The consequences were quite serious. More than 30,000 people were left without electricity. Fortunately, people were fine. That's because the locals are pretty used to derechos. However, the green sky is something different. It became a very unusual sight for the locals. Everyone was wondering why it happened. Was it a bad sign or a normal weather phenomenon? Well, to be honest, Scientists don't have an exact explanation, but although there are only assumptions, they sound pretty convincing. A green sky is a very rare phenomenon. Most scientists think that this happens when a powerful storm approaches the area before sunset or sunrise. Then the sky will turn green in this area. NBC meteorologist Bill Cairns, who once faced a similar event himself, suggests that the green sky appeared because of the huge hail before the storm. First, let's talk about why the sky looks blue, or any other shade, depending on its mood. In short, the sun simultaneously carries all the rays of the color spectrum. It may seem white to us in total, but it actually has all the colors at the same time. However, these color waves all have different lengths. For example, blue rays are shorter than the other ones. They jump away from the air molecules better than the red waves, so they reach us faster. Because of this, on a regular clear day, the sky seems blue. At the same time, red and orange color waves are very long and move slower, so they're usually left behind. But when the sun goes below the horizon or rises, the rays' directions change, and these waves reach us better. It all means that even if the sunrises and sunsets seem red and orange to us, in fact, there are still blue and green waves among them. But they have to bounce off something to reach us faster and become stronger than the red rays. Have you guessed what I'm getting at? This is where the water comes into play. Clouds are made up of water droplets. When they become large enough, but don't fall yet, for example, due to strong winds, they affect how the light behaves in the sky. Large, heavy storms mostly consist of water and hail, and water reflects blue and green rays best of all. That's exactly the reason why the water in rivers and lakes seems bluish-green to us, although in reality, it's transparent. And yeah, algae matter too. So, there are a couple of key factors why the sky may turn green. First off, the sun should be at the horizon level. Another factor is that while the storm clouds are approaching, they shouldn't cover the sky completely. There still must be a little room for the sun rays. Then, barely noticeable blue rays jump up to storm clouds. They're repelled by water droplets and hail. Mixing with the red sunset, they turn into a bright green light. And this green light is spreading all over the sky. That's why in most of these cases, when the sky turns green, people can only see it in the evenings. Yeah, it can also happen in the middle of the day. But since the conditions are already quite specific, seeing something like that during the day is even rarer. Still, if you see a green sky, you don't need to panic. It doesn't necessarily mean that a terrible storm is approaching. The chances are high though, but still, it's not a rule. It can be just heavy rain or a heavy hail. In other words, if you see a green sky, then you'd better hide, and hide your car. However, if you were lucky enough to see the stunning sky from the comfort of your own home, it's indeed very exciting. If you get a glimpse of something like that, just know that you had a chance to experience something very rare and special. Some people said it was the most incredible thing they had ever seen.
If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the U.S. every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain. And that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the U.S., and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the U.S. population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters, but areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern U.S. and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
Look at this ominous dark cloud. Is it rotating? What on earth is happening here? What you see is called a supercell. It's a storm, often a thunderstorm, that contains an updraft rotating about a vertical axis. That's why they're also called rotating thunderstorms. There are actually 4 types of thunderstorms: single cell, multi-cell, squall line, and supercell. Out of them all, supercells are the rarest and the most severe. They're typically isolated from other thunderstorms and last for 2 to 4 hours. Supercells are very common for the Great Plains of the United States, in particular, the area known as Tornado Alley. But they can occur in other parts of the world too. For example, in Europe, Argentina, Uruguay, and southern Brazil. These storms can be any size, large and small, high or low topped. Supercells are also associated with the most severe tornadoes, even though not every supercell can create one. These storms usually produce great amounts of torrential rainfall and hail, and are accompanied by powerful winds and downbursts. Downbursts are powerful winds that come down from a thunderstorm. Once they hit the ground, they spread out very quickly. These winds are dangerous since they can cause a lot of damage. Even though they're often confused with tornadoes, downbursts are a totally different phenomenon. Let's have a look at how a downburst forms. At the beginning of a thunderstorm, there's a powerful updraft. That's why the cloud grows vertically, and hailstones and raindrops start forming inside. The storm matures, and the updraft keeps feeding the cloud with unstable, moist air. Hailstones and raindrops are now big and heavy enough to fall to the ground. But sometimes, the updraft is so strong that it suspends huge amounts of hail and rain in the upper part and the center of the storm. But let's say some dry air gets into the middle and lower parts of the storm. It can cause a downburst. When it happens, all that amount of rain and hail from the upper part of the storm dashes toward the ground, dragging along a lot of air. All this mass gains speed, and when the downburst eventually reaches the ground, it's like a stream of water coming out of a faucet and hitting the sink. It spreads in all directions at an incredible speed, sometimes more than 100 miles per hour. But what you might most likely come across is called a microburst. It means that those terrible winds are confined to an area smaller than 2.5 miles across. While speaking about tornadoes, I can't but mention volcanic tornadoes. They're possibly one of the scariest natural phenomena. When a volcano erupts, it throws hot rock and ash high into the atmosphere. As for lava pieces and hot gases, they travel down the volcano's slope. When this flow is moving down, some of the gases trapped inside begin to rise and spin at the same time. They get squeezed by the surrounding air, which makes them spin faster and faster. That's how a volcanic tornado gets born. On the bright side, this phenomenon has a very short lifespan. If you ever see a tight burning column of air, that's a fire tornado, a creepy combination of whirlwind sounds and scorching inferno. This phenomenon is also called a fire twister or fire whirl. This dangerous natural phenomenon mostly occurs during wildfires. While burning, such fires create a big area of boiling hot air just above the ground. And when this scorching air gets mixed with the cooler air higher up, it results in a whirlwind that churns up burning debris and flames. The most powerful firenados can stretch hundreds of feet into the sky. Another dangerous natural phenomenon is called a snow squall. If you get caught in a snow squall while driving, you won't find a safe place on a highway, because this is an intense, but thankfully pretty short, period of heavy snowfall that comes along with powerful gusty winds, and sometimes even lightning. People have known about this phenomenon for quite some time, but the term itself, as well as the warning associated with this danger, appeared only in 2018. Another danger of snow squalls is something called a flash freeze. Come to think of it, it makes sense. Rapidly dropping temperatures and freshly fallen snow glaze highways very fast. This makes controlling your car almost impossible. The next curious phenomenon I'm going to talk about happens extremely rarely and is still poorly understood. It's usually not something big and turbulent. Dust devils can be tiny and vanish within minutes. They've got lots of names: whirlwinds, dusters, and sand spouts. Dust devils look like funnels of sand spiraling upward from the ground. But unlike their terrifying relatives, tornadoes, these babies are normally nothing to worry about. And still, according to the definition, dust devils fall in the same category as hurricanes and tornadoes. All three natural phenomena feature a column of air kind of spinning around an invisible pole. They're all formed during the collision of different types of air: moist versus dry, or hot versus cold, and so on. But hurricanes usually form over a body of water where cold air slides under warm air. Tornadoes spiral down from the sky when hot air rises through a mass of cold air, and dust devils form on the ground. Even though we call them dust devils, they can actually swirl any loose debris. The main criteria: the pieces have to be small and light enough to be lifted by a fast-moving vortex. By the way, do you know that some clouds can predict extreme weather? For example, shelf clouds. They look like something from a sci-fi movie. They form when warm and moist air gets caught in a thunderstorm updraft. These ominous clouds most often mean a storm is coming. Those huge white lumps over your head are called mammatus clouds. They can make you believe the sky is falling. Most clouds form when air rises into the atmosphere, but mammatus clouds appear when moist and cool air goes down and mixes with dry air. The result is these unique puffed rice clouds. By the way, if you see this phenomenon in the sky, bad weather is just around the corner. Morning glory clouds are extremely rare and harmless. They look like massive tubes stretching across the sky. They can snake for more than 600 miles, sitting relatively low. Most researchers agree that these clouds appear when an updraft squeezes through the cloud. This creates the signature rolling appearance. The cool air at the back of the cloud makes it sink downward. The best, but not the only, place to see the morning glory is Australia's Gulf of Carpentaria. If you decide to travel there to see these clouds, choose a period from late September to early November. Ever seen huge round disks in the sky? Most likely, those were lenticular clouds. They usually form over large and high places, like mountains or hills. When strong wind bumps into some barrier, this creates an air wave. The air kind of wraps around the obstacle. And the higher the barrier is, the colder the air that is rising over it becomes. At some point, the moisture it contains turns into water droplets, and they form these unusual clouds. Lenticular clouds can look like waves, a pizza, or even a stack of pancakes. And these clouds, on the contrary, form low in the sky and after some bad weather. Rainbow clouds appear on top of puffy low-altitude clouds after thunderstorms. They usually hover at the height of around 6,000 feet. When the water vapor they contain condenses, the resulting droplets act like prisms. This forms multicolored caps over the clouds. And a pretty scary bonus fact for you. One of the most common causes of wildfires is lightning from thunderstorms. But have you ever heard of a wildfire that triggered a thunderstorm? Well, now you know. It happened on May 11, 2018, not far from Amarillo, Texas. Then, the super powerful Mallard Fire not only created a massive dense cloud high in the air, but its heat also caused a violent thunderstorm that later dumped tons of quarter-sized hailstones 60 miles away in Wheeler County, Texas.